Just like we did with experimentation or experiments, with our next research method, which will be correlation, as you'll see from the title of this video, I want you to look at again at number 4. This is another method of collecting evidence. So before you can really know what the weaknesses or limitations of correlation are, you have to know what it is. And that's the goal of today's video lecture or this video, is that you understand what correlation is, including some examples. So although we're going through what correlation is, just always keep in mind number 4, use this in the context of critical thinking. For instance, if another person says there is a correlation between two variables, two things, then you know what that is and a potential weakness of correlation. So what is correlation? I want you to take a minute or two, push pause on the video, and answer these 4 questions right here. Go ahead and push pause now. Now imagine if we gave these 4 questions to every single person in the entire school. Essentially, we just gave a survey. Now, looking at these questions, you might imagine there might be a relationship between 1 and 2. In other words, if we looked at all 1,900 people in the school and looked at their answers, looked at their numbers, we might notice that the higher the percent on their test, maybe the higher amount of minutes they studied. And number 3 and number 4, we might notice there's a relationship between those two things. In other words, perhaps the more hours somebody works in a typical week, maybe the lower their GPA might be. This is what we mean by correlation. Is there a relationship between two variables? So imagine we did just that. Here's some hypothetical scores. Do not write this down. Bob, for instance, he got a test score of 40%, and he said he spent 30 minutes studying. I won't go through every single person. Let's just say these are a sample of people who responded to those questions. Now, you can probably look at these numbers and see a relationship. But imagine if we had not just 5 numbers, but 1,900 numbers. You couldn't just eyeball those numbers and determine if there's a relationship. That's what correlation does. It's essentially a mathematical formula. It's a mathematical calculation that will tell you the degree to which these numbers correlate. If one goes up, is it the case that the other number goes up? On this slide, please push pause now and write this out. Now that you've done that, label this a scatter plot. This is what we do with those numbers to see if there's a relationship between the two. This line that you see showing up on the screen right now is called a line of best fit. And as you can see, there's a general trend of those numbers going upward, or those dots I should say, going upward left to right. And if we actually calculated the correlation, which we don't have to do in this class, you'll never have to calculate a correlation coefficient, but just know it as the actual number of this relationship. This would be a positive correlation of 0.84, which is a strong, strong correlation. In other words, this is what's most important. The higher the test score, the more time people spent studying. Look at the number way, or that dot way on the right. The person who spent 60 minutes studying got a 90% on the test. Look at the very, very bottom left data point. The person who spent approximately 11 minutes studying got what, like a 34% on their test. So another way to draw this, if one number goes up and the other number goes up, that's a positive correlation. Let's look at our other example. If we did the same survey, Bob works 10 hours a week and his GPA was 3. Jerry works 13 hours a week and his GPA is 2. Again, do not write all these numbers down. We might notice a different type of relationship with these numbers. Instead of both numbers going up, in other words, high numbers for one typically means a high number for another one, it's the opposite. If you just eyeball those numbers, you'll notice more hours worked. For example, look at Marge. Marge worked 20 hours a week. Her GPA is low. It's a 1. Look at Phil. Phil only worked 2 hours per week, and his GPA is a 3.75, a higher GPA. So there's a relationship, but this is called an inverse relationship. Inverse relationship. As one number goes up, the other number goes down. This is what the scatter plot would look like for this data set. Push pause right now and draw this out. Just like on the previous slide, each one of those dots, or plus signs in this case, represents one of the people in the previous slide. Just plot it out on this X and Y graph. Here comes our line of best fit. Notice how the line goes down left to right. Still a relationship, but it's an inverse relationship. One goes up, the other goes down. In other words, the more hours somebody worked, typically the lower their GPA. This is called a negative correlation. Negative correlation. So just to review, that's what a perfect positive correlation would look like. Line going up left to right. This is what a perfect negative correlation would look like. For example, test grade as a percent in hours worked, or GPA. This is what no correlation would look like. If we did that same survey and we asked 2 questions, one question being what was your test grade on the most recent test as a percent, and then what's your shoe size, we wouldn't expect there to be any relationship between those two. In other words, people with big shoe sizes probably got high scores and they probably got low scores. We wouldn't expect there to be any kind of connection between those two. For those of you, especially seniors, maybe doing your BARPs sometime, and you're reading those peer-reviewed journal articles, you'll see this in papers with a little lowercase r. A perfect positive correlation is a 1. Perfect negative correlation would be a negative 1. No correlation would be 0. So they range from negative 1 to 1, with 0 being no relationship whatsoever. Now those are perfect correlations. In reality, as you're reading those peer-reviewed journal articles for your papers, those numbers on the previous page with 0.84 positive correlation, those numbers are just to illustrate the point. In reality, according to Cohen, just a 1992 resource, 0.5 positive or negative, that's considered a strong correlation. 0.3 is moderate, 0.10 is small. Another source for you, if you look over on the left, negative 1 to negative 0.5 or 1 to 0.5, that's a strong correlation. So anything 0.5 or above is a strong correlation in reality if you're ever crunching the numbers. And if you ever wanted to do this for a class, there's many online correlation calculators you can just use. And this is how you might use that table. Just another one. Don't write all these down, but just know that 0.5 is a moderate to high correlation according to this table over here. So that's what a correlation shows you. The biggest thing about correlation to know is this phrase. Write this in your notes in big, bold letters. Correlation is not causation. I'll repeat that. Correlation is not causation. If you've ever heard that phrase, that means sometimes people will present correlational data as causation when it's not. For example, in that example I talked about today in class, there is a positive correlation between the amount of times, the amount of spankings a child receives, and the amount of physical aggression that they demonstrate later in life. Now, Just because those two things are correlated does not mean one thing causes the other thing. Look at our examples today. There's a positive correlation between amount of time spent studying and test score as a percent. That doesn't mean them studying more caused them to get a higher score. There could be many, many other things that actually caused them to get a higher score. All that tells us is those two variables has a positive relationship. Here's an interesting example. This is a fact. There's a positive correlation between ice cream consumption and violence rates. If you look at a calendar year from January to December, the same time that ice cream consumption goes up, June, July, August, violence rates go up. That doesn't mean that ice cream consumption causes violence or that violence causes ice cream consumption. There's actually a third variable that's most important in this example, and that's heat or summertime. During the summertime, ice cream consumption goes up. And during the summertime, Omaha included, violence rates go up because people are out, it's warmer. So just because two things are correlated does not mean one thing causes another. That's what that phrase means. Correlation is not causation. So, in summary, and lastly, next time you hear somebody say there's a correlation between, you can stop them right there and say correlation is not causation.